Hello, and welcome to the Designing Impactful Innovation podcast. I'm Clara, your host. Today, we'll be talking about the changing landscape of the space industry and key essentials for success in an ever-evolving market. I'm handing the mic to Arvind Krishnan, industry analyst at Lifecycle Insights, and David Ziegler, vice president of Aerospace and Defense at Dassault Systems.
Hello, everybody. Today we have with us David Ziegler, who is the VP of Aerospace and Defense at Dassault Systems. David, welcome to today's podcast.
Hello, Arvin. Glad to join.
So, David, why don't we start by you telling us a bit about yourself and your role at Dassault Systems?
Sure. Well, I'm the Vice President of Aerospace and Defense for Dassault Systèmes, which, quite frankly, let me think that I've got the best job in the company. The reason is that because my job entails essentially two actions. The first one is to go all the way around the world, meeting with our aerospace and defense customers and trying to understand from them where the future is headed in terms of innovation for our industry. And the other way around, I'm leveraging the incredible work that is done by our R&D engineers at Dassault Systèmes, and I promote our virtual twin experiences to all aerospace and defense innovators. So that's quite exciting for a job.
Yeah, it looks like a very fun job to do, especially these days with a lot of new technologies and new companies venturing into space. So today we will talk about the new space industry. When people like me think about the space age, really we think of NASA, we think of Sputnik, we think of the Apollo program, we think of the European Space Agency. It is certainly dominated by the government players. Is the new space age different? Is there a role for small and medium sized private companies, David?
You're right, Arvin. Fundamentally, when we look back into the space age, we all think about Apollo and, massive taxpayers' money going into a government program. But it has changed quite a lot. You've seen in the recent years, of course, the epitome of this is SpaceX being the biggest space private contractor right now and very successful. But there are a lot of other companies that are joining the fray, huge companies like Amazon and Blue Origin, and a lot of others. But NASA has been leading the charge, and so is Europe, by the way, in terms of private contractors, with the European Space Agency or the French Space Agency having specific programs for startups. And by the way, so is India, that is leading the charge in terms of privatization of the space sector. So that's a fundamental change to that government led program, switching to more innovation and more technology actually going into space.
That is indeed a big shift, isn't it? I can sense opportunities, but also challenges. Let us start with the challenges. What are some of the key challenges facing companies participating in the new space?
Well, Alvin, if you're a new space company deciding to get into rocket science, there will be a lot of challenges. The first one, of course, is related to the access to space. It takes quite a long time to put your satellite into orbit, so you need to book your flight way in advance of your scheduled delivery time. And once it's your window, you need to make sure that everything are right the first time. So you've got definitely no second chance to lift off. So that's the point number one. I guess the number one challenge is to make sure that in terms of quality, you do everything right the first time. The second thing, or the second challenge, because there is a lot of competition out there, it's a developing market, but there are a lot of different competitors in there that wants to provide better satellites or better launchers than you. So you have a first mover advantage that you need to secure. You need to be the first one to get your product to market. Also, there is a big war on talents. There are not that many aerospace engineers all over the world. So people and companies are poaching talents from all over the world. So you need to be able to have your full team collaborating 24/7 on different continents, whether that's in the Silicon Valley or in the Space Valley in the US, or even in Europe, in Toulouse or Bremen, or even in India and other parts of the world. I guess the other challenges are really more technical. First, on the engineering side, we are having satellites that are getting much more smaller than before. So you need to work on a lot of integration, a lot of miniaturization on the electronic side, but as well a lot of integration between hardware and software. And finally, on the manufacturing side, we are shifting really from the fact of producing one satellite or two or three or four satellites for each company every year to manufacturing something like 200 or even 300 satellites for a year. So we need to shift from essentially being a craftsman doing one piece of art every year to being much more robust on an industrial system. This is, I believe, what are the main challenges facing the new space industry.
Wow, David, 300 satellites a year is pretty much like one satellite every day, even if you consider Sunday a holiday for satellite launch. That's a lot, right? I mean, with challenges come opportunities. At least that's the way I like to look at them. What opportunities are there for these companies and also for future startups who are yet to come? More importantly, what role does your company, Dassault Systems, play in helping these companies to exploit the opportunities?
Well, obviously, the opportunities are huge in the space market. I mean, any forecast is saying that essentially in 10 years from now, there will be 10 times more satellites orbiting the Earth. So a lot of opportunities abound into the manufacturing of satellites, of smaller satellites, what we call nano satellites, the size of a shoebox, actually, toward the access to space, to making new rockets that are going to be much more agile and that will be able to bring satellites much faster to orbit than what the big guys currently can do. So a lot of opportunities in there, and a lot of opportunities, of course, in satellite design, in services, in satellite operations. So how do we help these companies? That's a great question. The first thing we do at Dassault Systèmes is providing our customers with what we call virtual twin experiences. Essentially, a virtual twin is the ability for a company to design, simulate their satellite or their launcher into the virtual world before it even reaches production, which comes back to the challenge of that industry, which is to make sure you get things right the first time. You don't have a second chance to lift off. So leveraging our virtual twin technology and our ModSim technology, or modeling and simulation technology, proves to be very useful for new space companies. The second thing we're doing to help these innovators is essentially to provide them with a fully cloud compatible solution. The 3D experience platform is fully cloud compatible, which means that you can instantly set up an engineering and manufacturing environment that is available for all your collaborators, whether they're based in the US, in Europe, or in Asia. You can all collaborate and ramp up very fast, which is essentially the third challenge is that these companies have to face, which is international collaboration and the war on talents. Finally, much more from a technical standpoint, in order to really perform the integration of software and hardware and to move toward what we call product line engineering, you absolutely need a platform that is fully able to master the elements of model-based system engineering. And this is what we do. Essentially with Katia Magic, we're providing innovators with the capabilities to completely define the system architecture of their product into the virtual world, connect it to the physical design, and enable them to simulate all their different architecture trade-offs. And finally, move at the end toward product line engineering, therefore decreasing their cost of engineering. And finally, In order to address the manufacturing challenge, what we do is we are connecting the dots between engineering and manufacturing by providing the same platform, 3D experience platform, both for engineering and manufacturing, meaning that you've got full digital continuity and you're able to increase the rate of production, your scheduling, and your manufacturing right the first time. So this is essentially what we provide toward the startups, but also the major space companies out there. And we've got great examples on companies leveraging our 3D experience platform in order to redefine the extent of what's possible. For example, Virgin Galactic is leveraging the 3D experience platform to do the full design, but also to prepare for the manufacturing of their spacecraft. And they are now looking at how they can leverage the platform in order to follow that aircraft around the full life cycle, so from design to manufacturing to operations. We're also helping Airbus Space, which is the biggest space actor in Europe, to deliver from design to manufacturing their satellites. But also we are working with them on a specific project called the virtual twin of the Earth. Essentially, we are leveraging all the data coming from Airbus space satellites in terms of images from the Pleiad constellation, and we're working with them to provide the virtual twin of the Earth. So we are leveraging our simulation software portfolio to apply that toward essentially the images that are coming from the Airbus satellites to simulate, for example, what would be the events in case of a pollution coming into a big city. So we're looking at the weather forecast, at how the reconstruction of the city will prevent the wings from blowing up, and so on and so forth. So that's one example. And finally, I like to finish by another startup which I like very much, called Interstellar. Essentially, Interstellar is providing a biopod, right? It's a contained environment where you can grow plants. And that's going to be essential if you want to become a multi-planetary species. So essentially, Interstellar is using the 3D experience platform to develop these biopods and make sure that when we go to the moon or when we go to the Mars, humans will be able to grow plants by themselves into a contained environment. That's quite exciting.
Indeed impressive and very, very interesting and intriguing for people, common people, especially someone like me. It's really developing the entire ecosystem, not just a vehicle to transport people, but what you just said about Interstellar is really the whole ecosystem of producing food, creating an environment where plants can thrive. Indeed, fantastic. And we can't wait, and certainly you can't. And I certainly can't wait to see at least some of these things blossoming. Uh, you know, it is now very interesting that the space race, as you said correctly, is actually forcing companies to get things right the first time. They are also requiring them to collaborate extensively with different players throughout the world and actually absorb these things. I'm just curious about one little topic, right? It certainly looks like the impact of this new space is well beyond the aerospace or the space industry, right? And I think the impact is all over the global economy. Can you talk to us a little bit about this? And do you foresee this impacting citizens who are not really related to space technology or space ventures? And how is it going to impact other industries, other established industries in the world?
Obviously, the space revolution or new space is not limited to commercial aerospace as well. It's also impacting, the next very close domain is defense, of course, where you're seeing, unfortunately, a lot of militarization of the space above our heads, with a massive change into the satellites designs and war in space. But beyond defense, it impacts really, I would say, all the different aspects of our economy. Take, for example, transportation and mobility. You need actually some GPS signals to be able to drive your car. If you're going to move toward autonomous cars, you will need definitely to have more accuracy of your GPS system. You will need as well to have constant communication, even in white zones where you don't have a normal network satellites. This is why, by the way, you can think about Starlink that belongs to the same owner as of Tesla, and you can see the links between TNM and space right there. But essentially, if you take a more global view, what's going to happen is we are going to have more than 10 times the number of satellites that are orbiting the Earth today in operations 10 years from now. So you will have 24/7 monitoring of the globe across all aspects, whether that's optical, whether that's electromagnetics, whether that's communication. So essentially, we'll have a full coverage of the globe by satellites. And what is really changing as well is that all that data will be available on your smartphone, on your smart device. So that's going to change a lot of, that's going to enable a lot of different use cases across different industries. I talked about transportation and mobility, but you can see that, for example, in also very different industries like finance, by observing the Earth, you'll be able to follow the raw stock of materials all across the globe and understanding what's the impact in terms of financing in different markets. In the construction industry, you'll be able to monitor the project realizations, whether we are talking about buildings, whether we are talking about massive construction projects like bridges or even cities. You'll be able to monitor the progress 24/7 of all your construction projects. And it doesn't stop there. I mean, even in think about urban planning. Think about how to position your next generation 5G network. Where do you want exactly to position these antennas in order to optimize the placement of your network? There are going to be tremendous different use cases, and it's certainly going to impact the way we work on Earth. That's for sure.
Wow. You brought out a plethora of applications across multiple industries. And that is, David, if I understand you correctly, is the impact that we're going to see today, tomorrow. We're not talking about distant future, right?
Yeah, this is very clear. All these changes are happening right now. If you look, for example, there are many different platforms that offer geospatial analytics today. And today you can really measure all the statistical data about weather monitoring all across Europe, of course, but also having a look at what we call the virtual Earth of the twin. We're working with Airbus Space to leverage all of their images coming from their satellites and also leveraging our own simulation technology to simulate, for example, what would be the effect of a dispersant across a city if there were any problems happening on industrial sites. We're looking at different electromagnetic simulation as well across cities for 5G antennas. So that's not something that is going to happen in 5 or 10 years from now. It's happening right now.
Fantastic. I mean, that's going to shift the way people actually perceive. It really also talks about progress in real time where normal citizens can monitor what is happening. And I know you mentioned on cell phones, which is pretty much ubiquitous, considering throughout the world, people have access to both cell phone as well as fast digital internet on their cell phone. So it's really transparency. It's really being able to see the progress no matter where you are and no matter what is your placement in your economic sphere and so on. So that's really exciting. Now, David, this is indeed a major change that we are seeing and we will see in the very short future. But let's now look into a more distant horizon, maybe a longer term. What are the future trends in space and how do you envision Dassault Systems participating in this? I mean, very well, it could be after our times, I mean, as professionals, but something that you can talk to us about that.
So what's going to be the impact in 10 to 20 years is really difficult to forecast, right? Because of the so fast-paced technology. But as you know, in the future coming years, mankind has decided to come back to the moon. And I think that in the 10 to 20 years horizon, the plan is really to get to Mars and to make sure that some human guys are settling down on Mars. So we are going to resume deep space exploration here, and it will bring quite some exciting new opportunities in terms of technology. Think about it. If somebody is living permanently on Mars, you need a full support system. You need not only, the virtual twin of your product, but the virtual twin of your systems of systems, meaning your base, meaning the ships that are going to transport everything that you need in order to operate on Mars, but also the interactions and the simulations of humans in space. So that's a full new ballpark that is going to happen, I guess, over the next 10 to 20 years. And if that is the goal, if really the goal is to venture into more deeper space exploration, then you will need a lot of new capabilities. You'll need able to build spaceships in space. You cannot rely on building everything into Earth and spending a lot of money, time, and efforts to send everything upward in space. So you'll need to build more and more spaceship in space. And whether this is deep space exploration or even if our satellites need to stay in orbit much longer, we are going to see a saturation of the number of satellites orbiting the Earth, and meaning we'll need to work on sustainability, we'll need to work on debris removal from all these satellites. So in space manufacturing, in space tugging will be a big topic. And again, if we look further into the future, depending on the use case that we mentioned about geospatial analytics, we will require, in terms of capabilities, much more computing power in space. We cannot wait for all the data to come back on Earth and be treated locally. So you will have to have servers, networks in space that are going to work on specific analytics. So that's a full new industry. Think about the computer industry in space, actually.
Fascinating, David. Fascinating. Just looks like reading a new futuristic science fiction type of this one. But I guess even in the last 30 years, the progress that we have made in other areas, certainly these things are no longer just topics in science fiction textbooks. I'm very sure, in the future, our the next generation can look forward to many of the things you articulated. uh, so let me go back to a topic that is probably very relevant considering that we are in June and you are in Paris, David, and that really means the Paris Air Show, right? That must be a very big event for your city and also for Dassault Systems. Anything exciting we can look forward to from Dassault Systems at that event? What can you share with us today, considering that we are only a few days away from a really big event?
So right, Alan, it's not only a big event for Dassault Systèmes and for me, but I think it's a major event for all aerospace and defense professionals worldwide. This is essentially where all professionals are gathering in order to define the future of aerospace. So with that in mind, we'll have the pleasure in our chalet to demonstrate to our customers, to our partners, the latest solutions. We'll be able to demonstrate how much progress we've made modeling and simulation with virtual twin experiences, with model-based system engineering, and really all the capabilities that are required to innovate at scale, as I mentioned before. So that's what's exciting. And on top of that, we'll have different roundtables with senior officials. In the case of space, we will be able to dedicate the full Thursday towards space, and we will be discussing especially how geospatial analytics can improve life on Earth with some very interesting people. like the director from Carista Space, a private equity outfit, professionals coming from Airbus Defense and Space and the European Space Agency. So I'm really looking forward to that show coming up now in actually 14 days from now.
Right, right. I wish you the very best with the air show, and I wish Dassault Systems and also your team a fantastic space show in Paris. Right. I really look forward to seeing those new announcements and the new demonstrations that you mentioned, and also some of the exciting stuff that you probably will unveil during the Paris show. So, David, thank you so much. It was really a pleasure talking to you today. And you educated us quite a bit today on what's coming in space, what's happening right now, and what we can foresee in the distant future. And also, thank you for sharing with us all the Dassault Systems technology that enable new and upcoming startups and established players actually make this exciting space journey very exciting for not only them but also for all the humans in the planet today. Thank you so much. It was a pleasure again talking to you.
Thank you, Arvind. Let's make it fly together.
Thank you for listening to Designing Impactful Innovation. To find out more, go to 3ds.com/cloud. Don't forget to subscribe for more insights and stories from our guest experts.